Hello and welcome to AMARI Studios. My name is Emmanuel and I'll be taking you in math. So today we're going to revise a past paper for grade 9, paper 1, 2023. So the first question, it reads, write for 41.956 and correct to 2 decimal places. Write 41.956 and correct to 2 decimal places. So the first thing that you need to consider is that when you talk about a decimal place, it's actually a number, or should I say numbers after the point there. So as you can see, 9, 5 and 6, these numbers, they're after a point, so we consider them to be called decimal places. And so the question is saying write and correct them to 2 decimal places. So what we are going to do is that we'll count 2 numbers after the point, which in this case will be 9 and 5. Then now there is a rule in rounding off. When you are rounding off a number which is greater than 5 or equal to 5, it always rounds off to 1. And then when you are rounding off a number that is less than 5, for example 4, 3, 2 or 1, it always rounds up to 0 there. So now what we are going to do is this. Since they've said 2 decimal places, we'll count 2 numbers after the point, 1, 2, and then we are going to write 41. 41, we write it just like that as a whole number. Then we say point. Then now, since the number that is in front of 5 is 6, and then we say that any number that is greater than 5 or equal to 5 can be rounded off to 1. So we are going to round off this 6 into 1, then we're going to add it on the next number there, which is in this case 5, of which the answer there is supposed to be 9. Then if we round off 6 to 1, 1 plus 5 is supposed to be 6 there. So meaning that this is supposed to be your answer, 41.96. They say 2 decimal places, and as you can see, we are left with 2 decimal places there. So that's the first question. We move to the second. Question 2, it says, which of the following shape is used to represent the start of a program? Which of the following shapes is used to represent the start of a program in a flowchart? So we have A, they have given us a decision box, which is more like a diamond. We have B, this is our A. B, we have a parallelogram. Then C, we have a rectangle. Then lastly but not the last, D, we have an oval. So now, which of these shapes represent the start of a program in a flowchart? So the diamond there, it represents a decision box because this is where decisions are made. And then when you talk about a parallelogram, it actually displays, or it shows the output or the input of the flowchart. Then we have a rectangle there. A rectangle, it shows the processing of the program. Then lastly but not the least, we have an oval, which in this case represents the start and the end of a program. So if you see a flowchart, the first shape that is going to be there will be an oval shape. As you can see, an oval, it represents the start and the end of a program. So the answer there was supposed to be D. Let's move to question 3. Question 3 is saying find the value of 11 plus -4. Find the value of 11 plus, open and close brackets, we have -4 there. So now the first thing that you do when solving an integer is to consider the sign, because signs are very important. So now what we're going to do is this. This is 11. Now as you can see, in the middle there we have about two signs. We have a positive sign and a negative sign. And then according to what we have been learning in math, most of the times we always find out to say that on the middle there's supposed to be one sign. So now what are we going to do now in this kind of problem? So we are going to multiply these signs. We'll multiply them. We'll say, since this is a positive and then this is a negative, we multiply a positive by a negative. Remember, the brackets, they represent multiplication. So positive times negative, it gives you negative, of which that is minus 4. Then 11 minus 4 there, it is going to give you 7. 7 is going to be your answer there. Remember, since we have different sign, 11 has a positive sign and then 4 has a negative sign. You subtract the numbers and you get the sign of the bigger number, of which our bigger number here, it is 11, which has a positive sign. So meaning that your answer here, it will be positive 11. Then according to the question here, it was supposed to be B. That is your answer there. Let's move to question 4. Question 4 is saying, John spent. Listen carefully to the question. John spent the following hours to study. John spent the following hours to study. So we have 3 hours, we have 1 hour, we have 2 hours and another 2 hours, and then we have 0, we have 1, we have 2, we have 3, and lastly but not the least, we have 2. The question is saying John spent the following hours to study. So these are the hours that John spent on studying over a period of 9 days. The question is saying, can you find the mode? So this question is actually a statistics question. And then when you are solving what we call a mode is actually a number that appears more frequently in the statistics there. A number that appears more frequently. So as you can see, we have a number here which is 2. 2 is appearing more frequently. As you can see, we have 1. This is the first 2. Then we have 2, 3, 4. And then so you can tell that 2 is appearing 4 times. 2 is appearing 4 times in the statistics that was given. So it means that the mode of these statistics there, it was supposed to be 2. And then according to our answers there, we have A 0, B we have 1, then C we have 2, then D we have 3. So meaning the answer there, it was supposed to be C, which in this case is 2. I hope you're following me closely. Please feel free to pause the video and rewind it a little bit, then you can continue on solving there. So the next question is question 5. Question 5 is saying find the value of 6 to the power 2 plus we have 3 to the power 3. 6 to the power 2 and we have 3 to the power 3. So now the question is clearly stating find the value. So how are we going to find the value? The first thing that we're going to do, we need to evaluate what we call the powers there. So the powers here, they represent the indices, which are the numbers on top of the bases there. As you can see, we have a 2 here and we have a 3. So 2 and the 3, they represent a power. So now what we are going to do for us to solve this question, we are going to evaluate the powers. How? So as you can see, this power 2 here, this power 2 is actually saying, or it can be interpreted as 6 is multiplying 2 times by itself, is multiplying itself 2 times. That's what the power means. So meaning that 6 to the power 2 is the same as saying 6 times 6 plus 3 to the power 3 is the same as saying 3 times 3 times 3. Because there's a 3 there, it means that 3 was multiplying itself 3 times. So now if you say 6 times 6 there, it's going to give us 36 plus 3 times 3, it will give us 9 times another 3, it will give us 27. Then when you add these two numbers, you are going to get 6 plus 7, that is actually 13, which is 1 3 remainder 1. Then we have another number here, which is 3 plus 2, it is 5, plus the remainder, it is 6, meaning 36 plus 27 is supposed to give you 63. And then according to our multiple choices that were given in this past paper, the answer there was supposed to be A, which is 63. So we move to the next question. The next question is saying, which of the following is an irrational number? Which of the following is an irrational number? Let's see which numbers are given. We have A, 1/8. We have B, 1/5. We have C, which is the square root of 4. And then we have D, which is actually the square root of 7. Which of the following is an irrational number? So when you talk about an irrational number, is a number that cannot be expressed as a fraction. A number that cannot be expressed as a fraction. So as you can see, A has been expressed as a fraction. We have B, which is also expressed as a fraction. Then again, what you need to understand is that all irrational numbers, they have perfect squares. So here, the square root of 4 there, it is 2. So meaning that 2 there is 4 is a perfect square. Why? Because the square root of 4, it is 2. But the square root of 7, it's actually not a perfect square. So meaning that upon this question, we can say that D here was actually our irrational number. The reason being is because D, number 1, it has no perfect square, and then number 2, it cannot be expressed as a fraction there. So D here was our number, which is the square root of 7. The square root of 7. So without wasting much of our time, we move. Question 7 is saying, give me just a moment, I clean my board. They say cleanliness is next to godliness. Alright, so question 7 is saying, given that x degrees and 44 degrees, take note of that. Question 7 is saying, given that x degrees and 43 degrees, given that x degrees and 43 degrees are complementary angles. Take note of that word, complementary angles. Find the value of x. So now, for us to find the value of x, our keyword there, it was a complementary. They're saying that these two angles, they are actually complementary angles. So now, when you talk about complementary angles, we are talking about two angles which when you add them, they will actually add up to 90. So in short, complementary angles, it is the sum of two angles which adds up to 90 degrees. So it means that if you say x degrees and 44 degrees, they are complementary angles. It means that when you add x degrees plus 43 degrees, if you add these two numbers, they're supposed to give us how? 90 degrees there. It's supposed to give us 90 degrees. So now, as you can see, this is an equation. So we'll say x degrees is equals to 43 is going to come on the other side where there is 90. Then it will be 90 degrees minus 43 degrees. Then when you subtract these two numbers, you are going to get 47 degrees as your final answer there. And then according to our question, our answer there is supposed to be C. According to our question, our answer is supposed to be C. I hope you have gotten that. Okay, so we clean the board again. We move to the next question. In the following diagram, triangle ABC and triangle ADC are congruent. Take note of that word, congruent. We have a triangle there. We have a triangle and then another triangle there. Okay. So the question is saying, in the following diagram, triangle ABC are congruent. So that is my D, that is my C, and that is my A, and that is my B. In the following diagram, triangle ABC are congruent. So when you talk about congruent triangles or congruent shape, we are talking about shapes that have the same interior angles, meaning that the angle that are supposed to be in triangle ADC are supposed to be equal with the angles that are supposed to be in triangle ABC. So now the question there is saying which of the following angles are equal? Which of the following angles are equal? So we have we have angle ADC, we have ADC and ACD. Then B, we have ACB and angle CAD. Then C, we have ADC and angle ACB. Then lastly but not the least, we have D, which is angle ADC and angle BAC. So the question is again, which of the following angles are equal? So now let's start with A. They're saying angle ADC. So as you can see, this side is equal to that side, and then this side is also equal to that side. So now the first multiple choice is saying angle ADC, angle ADC. Let's see which one is angle ADC. Angle ADC, meaning this angle here is equal to angle ACD, of which that is actually not true, because this angle cannot be equal to that angle. You see, this angle cannot be equal to that angle, so meaning that A is disqualified there. Then we have multiple choice B. They're saying angle ACB, meaning that this angle here is equal to angle CAD, meaning that this angle here. So now as you can see, our answer here is supposed to be B. The reason being is because this side is equal to this side, meaning that the angle that is here is also equal to the angle that is over there. And then without even wasting much of the time, you can even see that DACB, it forms a Z. It actually forms a Z if we remove AB, and then if we remove DC, it forms a Z. And then the angles in a Z is mostly formed by parallel lines. So as you can see, CB and DA, they are actually parallel lines. So now if these guys are parallel, it means that the alternate angles of these two lines are going to be equal. So this angle here will be equal to that angle there. So this is a Z. That's the rule when you are dealing with angles in parallel lines there. So we call them alternate angles. So alternate angles, they are always equal. So meaning our answer here is supposed to be B. Why? Because DAC, which is CAD, is also equal to ACB there. Like I said, feel free to pause the video. If you haven't gotten it correct, you can actually rewind a bit, then just in case if you might have missed something. We move to the next question. Question 9 is saying the Venn diagram below shows sets A and B. So we have a Venn diagram. Please follow me closely. Okay, that's our Venn diagram, and then this Venn diagram is this set is A, that set is B, and then we have the mother set, or also known as the elemental set here. So it's saying that the Venn diagram below shows set A and B. The question is saying, can you describe the shaded region? So this region is the one that is shaded. This is the region shaded. Let me use a blue marker. Okay. So that's the region that is shaded. As you can see, that's the region that is shaded. And the question is saying, can you describe the shaded region there? Describe the shaded region. So how are we going to describe the shaded region? So as you can see, this one is actually simple and straight, and it is also forward. So the best thing that you can do, they want us to describe the shaded region. So what we are going to do is that we are going first of all to describe the unshaded region. So the region that is not shaded here, it is the intersection part of A and B. So it means that you are going to write A intersection B. I'll repeat what I've said again. So they want us to describe the shaded region. So for us to describe the shaded region, we first need to describe the unshaded region. And then the unshaded region here in this question, it is actually the intersection part of A and B. So you're going to write A intersection B. So now, since the intersection part was not shaded, how are we going to find this? So as you can see, A intersection B was the part that was not shaded. So now, if this part was not shaded, then how are we going to describe the shaded region? So what you need to understand is that you're going to write A intersection B, then put them in brackets, then you write complement there. Because we are saying that what this complement means, it means that you can shade any part of the diagram apart from the intersection set. So you say A intersection B, then complement. The complement, it means that you can shade any part of the diagram apart from the intersection set, meaning that you need to exclude the intersection set. So our answer here of describing the shaded region is supposed to be A intersection B, closed and open brackets, complement there. And so according to our question here, the answer, it was C. According to our question, the answer, it was C. Then we move to the next question without wasting much of our time. Let's move to the next question. Allow me to clean my board. Okay, there you have it. You'll find such questions in the past paper, and then there's no need of you using a calculator because this is paper 1. You have to use your head. So we move to question 10. Question 10 is saying, how many faces does the solid below have? So we have been given a triangle. Okay, we have a triangle there, and then some dotted lines. Okay, so the question is saying, how many faces does the solid below have? How many faces does the solid below have? So this is actually a pyramid. Specifically, it is a triangular pyramid. So now, a triangular pyramid always has three faces. A triangular pyramid, it always has 3 faces. The reason being why I'm saying that a triangular pyramid has three faces is because of you have even heard from what I'm saying. I'm saying triangular. A triangle always has 3 sides. A triangle has 3 sides, and the base of this pyramid is a triangle. So it means that it's going to have 3 faces because a triangle always has 3 sides there. So our answer there is supposed to be 3. So the question there, it is saying how many faces does the solid below have? So our solid here is going to have 3 faces. This is a triangular pyramid. If the question said a square based pyramid, a square has 4 sides. So meaning that the number of sides of the base is going to be equal to the number of faces the pyramid will have. And then our base here, it is a triangle, and then a triangle is equivalent to 3 sides. So it means that the pyramid is going to have 3 faces. Like I said, the sides of the bases are always equal to the number of faces the solid is going to have. So that is our multiple choice question, and that is the end of our multiple choice question 10. I hope that this past paper or this revision was helpful to you. And then if you want to see more videos of us, you can actually click on that button, subscribe. So see you next time.